Hey guys, this is the first section after Christmas break, um, solving quadratic equations with complex solutions. Now, if you remember just before the break what we covered, just before the break we talked about complex solutions. We talked about imaginary numbers. So to kind of just refresh us on what that is, we talked about imaginary numbers. An imaginary number was I. And I meant a specific amount. I was equivalent to the square root of -1. So we use this to create imaginary numbers and complex numbers. So we're going to be using these complex solutions today. Now, how can you determine whether a quadratic equation has real solutions or imaginary solutions? And we talked about this before last time, but a quadratic equation will have real solutions when the quadratic function, crosses the x-axis. It crosses the x-axis at real numbers. It will have imaginary solutions if it doesn't cross the x-axis. So if it looks something like this. So here it doesn't cross the x-axis, so therefore it's going to have imaginary solutions to it. So for this next question it says describe the number, so how many solutions, and the type of solutions. The type of solutions being real or imaginary. Determine the number and type of solutions of x squared plus 2x plus 3 equals 0. And how do you know, and what are the solutions? So how can we determine the number and type of solutions this has? Well, we can graph it for one. We can graph it in a calculator and see what the graph looks like. So let's go ahead and try that out. So we have x squared plus 2x plus 3. So when we graph this, you can see here that we don't cross the x-axis. Our parabola, our quadratic equation, is above. So by graphing, we know that there are still two solutions, but they are imaginary. And we know that because we graphed it. Another method of doing this is to use the determinant. Now, if you remember the quadratic formula I'll write up here was x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. The determinant was what was under here. Sorry, I meant to say discriminant. The discriminant is b squared minus 4ac. And now, if this is negative, then you're going to have imaginary. So let's just test it. We already know, but let's just test it. So in this equation, a is equal to 1, b is equal to 2, c is equal to 3. So if we plug this in here, b squared, which would be 2 squared minus 4 times by a times by c, is equal to 4 minus, so this is going to be negative 4, and then negative 4 times by 3 is negative 12, so 4 minus 12, which is equal to negative 8, and so therefore, because it's negative, it's going to have two imaginary solutions. So that's two ways of checking, is by the graph or by using the discriminant. So let's go ahead and check this one right here. So finding the zeros of the quadratic function. So we want to find what the zeros of the function are. So we have f of x is equal to 4x squared plus 20. Now what we want to do here is solve for x when y is 0. So let's go ahead and do that first. Let's set f of x equal to 0. Alright, now we can solve for x. And just so we're more familiar with it, I am going to move it so that it's on the other side. So that it's 4x squared plus 20 equals 0. So to solve for x, I'll subtract 20. So 4x squared is equal to negative 20. Divide by 4. So x squared is equal to negative 5. And I take the square root. So x is equal to plus or minus the square root of negative 5. Now we have a negative number underneath our radical, which means this is equal to plus or minus the square root of negative 1 times the square root of 5. And the square root of negative 1 is equal to I. So x is equal to plus or minus I square root of 5. And we can't reduce or do anything else about the square root of 5. Okay, and there we go. Those are the solutions. Those are the zeros of the quadratic function. Now let's come down here and do the same for these three problems right here. Solve the quadratic equation. So starting with A, we have x squared plus 9 is equal to 0. And this one's just like the one above. We can solve it just as it is. So we can subtract 9. And x squared is equal to negative 9. Take the square root. So then x is equal to the square root of negative 9. Plus or minus the square root of negative 9. Now let's do this. So we have x is equal to plus or minus. Let's split this up to be the square root of negative 1 times the square root of 9. Square root of negative 1 is I, and the square root of 9 is 3. So if we were to write this in the appropriate way, this would be x is equal to plus or minus 3 times I. And those are the two solutions to the equation. Now let's try B. So x squared plus 4x plus 5 is equal to 0. Now this one right here, we can't solve it like we did before because we have this middle term right here. So what we should do instead is we should use the quadratic formula. Quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. In this case, a is equal to 1, b is equal to 4, and c is equal to 5. So x is equal to negative b, that'd be negative 4, plus or minus the square root of b squared, so that's 4 squared minus 4 times by a times by c, all over 2 times by a. So let's simplify the discriminant first. So negative 4 plus or minus. So 4 squared is 16. Negative 4 times 1 is negative 4, and negative 4 times by 5 is negative 20. All over 2. So negative 4 plus or minus, and the square root of 16 minus 20 is negative 4. So x is equal to negative 4 plus or minus. Now I know negative 4, square root of negative 4. Since it's a negative, I'm going to take out an I, or I know that there's going to be a square root of negative 1 in there, so there's going to be an I. And then there's going to be the square root of 4, and the square root of 4 is 2. So this will simplify to be 2I, this is divided by 2. So whenever we have a fraction like this, we can divide both terms on both sides of the positive or negative, divide that by 2. So this is negative 4 divided by 2 plus or minus 2I divided by 2. So that's equal to, so negative 4 divided by 2 is negative 2. And then here, the 2's will cancel. So plus or minus I. And that's our solution right here. Those are the two solutions, negative 2 plus I and negative 2 minus I. And that's a complex number right there. Okay, for C, we can do the same exact thing. And I want you to try this on your own. I'll help you get started. But we have 5x squared minus 4x plus 1 equal to 0. So we're going to use the quadratic formula again. X is equal to negative b plus or minus the square root of b squared minus 4 times by a times by c, all over 2 times by a. A is equal to 5, b is equal to negative 4, c is equal to positive 1. And then if we were to write up first, so x is equal to negative b, so b is negative 4, so negative b will be positive 4, plus or minus the square root of negative 4 squared. Now remember, negative 4 squared is the same thing as 4 squared, because it's negative times negative 4 times negative 4, which is going to be positive 16. So don't get confused on that part. So negative 4 squared minus 4 times by a times by c, all over 2 times by a. So there's the setup. So go ahead, simplify the discriminant, and then try and solve for the rest. And that should be it for today, and that should be what you need to know for your homework.